This chapter we're going to be talking about force and Newton's laws.
I'm going to be talking about Newton's first law.
I'm going to be talking about Newton's second law.
And I'm going to be talking about Newton's third law.
Go.
In Newton's first law, the first thing it starts to talk about is force. With force, you have a push or a pull motion that one object applies to it. Like me pushing on the computer case is a force of pushing, which makes the computer case move. Net force is a combination of all forces acting upon an object. Two examples would be an unbalanced force and a balanced force. A balanced force would be like, so the object won't move in one way or the other, it stays in the same spot. An unbalanced force would be like, well, the object goes one way because one force will outrule the other force. Newton's first law of motion states that if an object has a net force of 0, it will remain as stop unless it was already in motion. If it was in motion, it will continue at a constant speed until another force acts upon it.
Go.
So friction is a force that stops everything in motion. Friction is what causes the water bottle to stop from sliding any farther.
Do it again.
Just delete the clip.
Bloopers.
Delete. Friction is a force that will stop anything in motion. Friction would be like, since the water bottle stopped from sliding any farther, the friction is what caused it to stop from sliding. So, since I already showed you sliding friction, I'll show you static now. Static friction would be like me trying to move this table. The table would be hard to move because it has rubber stops on the bottom of it down here that rub against the floor to make it harder to slide. And then for rolling friction, if the table is in the up position, so it was resting on the 4 wheels, it'd be easier to move because the wheels go at a rolling motion.
So, Newton's second law of motion is acceleration equals the net force divided by mass. To get net force, you have to times mass by acceleration. Say
Go.
3, 2, 1, go. You say 3,
Go.
2. Are you videotaping it? Alright, anyway. Okay, the force of gravity is the attraction between any two objects, like this paper ball and the ground. Gravity would attract this paper thing to the ground. Weight is the gravitational push on an object. That can be measured using this equation. Weight equals mass times 9.8 meters a second squared, because this is the force gravity has on you. Weight is the gravitational push on an object. That can be measured using this equation. Weight equals mass times 9.8 meters a second squared, because this is the force gravity has on you. So, based on Newton's second law, the direction of velocity goes the way of the force. So my hand is the force going on the object. Friction is what makes it stop. So the friction is coming this way. Well, actually it's going this way based on the bottle. And the bottle's velocity is going this way, so they're going against each other.
Go.
Also, since you're constantly accelerating, there must be a force acting upon you at all times. While this paper is falling, it's acting on air resistance, and this hole would have been the center of mass. And the center of mass is the middle of your mass, pretty much.
So I'm going to be talking about Newton's third law of motion. Newton's third law of motion states that everything has an equal but opposite pair of motion. The forces exerted by two objects are often called action and reaction force. So say I jumped. The way I jumped would be the reaction, and the action would be the opposite way I jumped. Going back to Newton's third law, it said that it has equal but opposite pair of motion. So reaction, action would be the opposite way I go. So if I turned around, that would be reaction, and the other way would be. So now we're going to be talking about weightlessness and what a scale measures for your weight. When you step on a scale, Newton's third law pushes on the scale to equal your weight, to measure your weight. So suppose you were in an elevator, you were standing on a scale while the elevator was free falling. The scale, when you'd step on the scale, you'd be free falling downwards. So the velocity of the elevator would be measuring the weight of you while the elevator is free falling. So your weight would be 0 to none.